Somewhere in East Africa, about 1 million years ago, a bolt of lightning hit a dry patch of grass and did something no other animal on Earth had ever thought to do anything with. It burned, it spread, and then at some point it went out, the way it always had for the 3 billion years before that moment. Except this time, one particular ape-like creature didn't walk away. It's easy to skip past this part of the story, because we already know how it ends. Cities, engines, stovetops, birthday candles. But strip that away for a second. Imagine that same creature standing in front of the flames and simply not understanding what it was looking at. No word for it, no idea it could be kept alive, no idea it could be carried. What if it had stayed that way? What if that spark had gone out, and the next one, and the one after that, for another 100,000 years? To answer that, we first have to be honest about what fire actually did for us, because the story we usually tell, cavemen huddled around a campfire for warmth, massively undersells it. The biggest thing fire gave humans wasn't heat, it was digestion outsourced to a flame. Cooked food breaks down easier than raw food, and that sounds like a minor convenience, but the numbers are not minor at all. Chimpanzees, our closest living relative, spend somewhere around 6 hours a day just chewing, not eating, chewing. Their jaw muscles, their gut length, their entire skull structure is built around the brutal, grinding work of processing raw plant matter. Once cooking entered the picture, human jaws could shrink, human guts could shrink, and the energy that used to go toward digesting raw food, a genuinely expensive biological process, got freed up for something else. That something else was almost certainly the brain. The human brain burns through roughly 20% of our daily calories, despite being about 2% of our body weight. No other primate can afford that kind of energy bill on a raw diet. Some researchers argue, fairly convincingly, that without cooked food, the brain size we take for granted simply never happens. Not slower, not delayed, different. So the first thing that disappears in a fireless timeline isn't warmth, it's us, more or less, in our current form. Assume for a moment that a smaller brain, still clever hominin manages to survive anyway, cooking or no cooking. The next problem shows up the moment the sun goes down. Night, for most of animal history, belongs to predators, big cats, hyenas, things with better night vision and faster reflexes than a mostly hairless primate walking on 2 legs. Fire didn't just provide light, it provided a kind of forced truce, because almost nothing wants to walk toward a burning branch, no matter how hungry it is. Take fire away permanently, and the human relationship with darkness never gets renegotiated. Groups stay small, because bigger groups need more defended space, and there's no easy way to defend a perimeter at night without it. Migration into colder climates becomes close to impossible, not difficult, impossible, because there's no way to survive a European or Siberian winter on body heat and animal skins alone. Every population that tried would have simply died there. Which raises an interesting, slightly unsettling point. The out-of-Africa story that eventually populates the entire planet may not happen at all. Humanity, in this version of events, possibly just stays put, one continent, one climate band, for a very long time. Now, stone tools don't require fire, and early humans were sharpening rocks long before anyone figured out how to keep a flame alive on purpose, so it's not as if a fireless species stays completely primitive. But here's where it gets genuinely limiting. Metal does require fire, not helps to have, requires. You cannot smelt copper, let alone iron, without sustained, controlled heat far beyond what sunlight or friction can provide. No smelting means no metal tools, no metal weapons, no metal anything. Pottery requires fire too, which means no durable containers for storing grain, water, or anything else long term, which in turn makes it much harder to stockpile food and survive lean seasons, which makes larger settled populations far less stable. Glass requires fire. Ceramics require fire. Basically, every technological leap past sharpened rock runs through combustion at some point. A fireless humanity isn't a slightly slower version of our history, it's a version that hits a hard ceiling somewhere around the Stone Age, and as far as we can tell, has no obvious path past it. It's worth asking, at least briefly, whether some other species might have picked up the slack, evolved its own way of controlling heat, or developed some entirely different technological path that doesn't run through fire at all. As far as the fossil and archaeological record shows, that never happened, anywhere, with any species in over 3 billion years of life on Earth. Every technological civilization we know of, which is admittedly a sample size of one, got there through fire. That's either a coincidence worth being suspicious of, or it's telling us something about how narrow the path to intelligence-driven technology actually is. There's a sobering angle buried in that. If fire really is that close to a hard requirement, then the spark that hit that dry grass 1,000,000 years ago wasn't just useful, it might have been the single most important accident in our entire evolutionary history. More important than any specific mutation, any specific migration, any specific tool. So picture that alternate branch still going, somewhere on a savanna indefinitely. Small, scattered bands, sharpened stone, maybe, no metal, no pottery, no writing, since writing was invented partly to track stored grain surpluses that a fireless society could never really build in the first place. No permanent settlements past a certain size, because without cooking, without preserved food, without light and warmth to push back the night, there's a hard cap on how many people a single group can support and defend. No spread beyond the warm latitudes, because nothing survives a cold winter on nothing. It's a strange thought experiment because it forces you to realize that almost nothing we consider distinctly human, language complex enough for abstract ideas, cities, art, science, sits downstream of brain capacity we may never have gotten in the first place. Not because we wouldn't have been smart, in some sense, early hominins clearly were in their own way, but because the energy for that kind of brain has to come from somewhere, and for us, it came from a flame someone decided to keep alive. So the actual history is a little strange to sit with. Nobody invented fire in the way we usually think of invention. Nobody designed it. Someone simply refused to walk away from something the sky handed them for free. And then, generation after generation, other people kept doing the same thing. That one habit, not walking away, is arguably the single decision every later human achievement was built on top of. Every fired brick, every smelted blade, every cooked meal that let a slightly bigger brain grow into the one you're using to process this sentence right now. So the next time a stove clicks on or a lighter sparks, it might be worth remembering that the gap between that and nothing, altogether, permanently, is thinner than it